Here we have a pre-calculus problem on compound interest. Okay, let's go over the question. Joe invested $4,500 at a fixed annual rate, annual interest rate compounded annually. At the end of 12 years, the investment has doubled in value. To the nearest hundredth of a percent, Joe's investment pays interest at dash percentage per year compounded annually. Okay, first let's write the formula for compound amount, that is A equals to P times 1 positive R over N to the power N times T. Here, let's understand the components of this formula. Here, A stands for the accumulated value or the final value of the deposit, and P stands for the initial value of the deposit, and R stands for the rate of interest, and N stands for the number of times interest is compounded per year or number of conversion periods per year, and T stands for the time period of the investment in years. Okay, in our problem, so the value of P is given, that is the initial value of the deposit, that is $4,500 times 1 positive. R is unknown because we have to find the value of R because they are asked us to find to the nearest hundredth of a percent. So Joe's investment pays interest. So we have to find the value of R. So let's keep R as it is. And here N is 1 because the question says it's compounded annually. So that is the number of times interest is compounded per year is just 1 when it is compounded annually. So the value of N is 1. So here also we can plug in N is 1, and T refers to the time period of the investment in years. So it is given that is 12 years. So it's 1 times 12. And so in 12 years, the investment has doubled in value. So what is the initial value of our investment? It's $4,500. If it has doubled in value, then the final value of the deposit will be 2 times of this 4,500, which is $9,000. Okay, now I just plugged in the values for A, P, N, T. So now in this equation, I have to solve for R. Okay, now for my first step, what I'm going to do is I'm going to get rid of this 4,500. So for that, I divide both sides by 4,500. So I get, so this one will cancel out. 4,500 goes into 4,500 one times, and 4,500 goes into 9,000 twice. So we get 2 on the left side. On the right side, we have 1 positive. R over 1 can be written as just R to the power 12. Okay, to solve for R over here, I have to get rid of the exponent 12. So how can we get rid of this exponent 12? So I have to raise both sides of this equation to the power of 1 over 12, so that I'll be able to get rid of this exponent 12. Okay, let me raise both sides to the power of 1 over 12. So then I'll be getting 2 to the power of 1 over 12 equals to 1 positive R to the 12th power whole to the power 1 over 12. So here I can write this 2 to the power of 1 over 12 as it is. Okay, here I can use the power of a power rule in exponent. That is, we have base A, for example, let's consider base A, and let's say we have exponent M for base A, and for the complete stuff, again we have the exponent N. So whenever we have 2 exponents like this, we can multiply the 2 exponents, that is, then we'll be getting A to the power M times N. Actually, this is a power of a power rule in exponents. So here we have the base 1 positive R, and we have exponent 12, and for the complete stuff we have exponent 1 over 12. So what we can do is we can multiply these 2 exponents. So I'll be getting 1 positive R to the power 12 times 1 over 12. So this 12 will cancel out. And also we can get the value of this one 2 to the power 1 over 12 using calculator. Then we'll be getting 1.05946, and it keeps going. And on the right side we have 1 positive R to the first power. So whenever we have first power, it can be ignored. Simply we can write the base, that is 1 positive R. Okay, and also we can round this value to 4 decimal places. So we'll be getting 1.0595. So because the digit of the 5th decimal place is 6, so whenever this value is 5 or greater than 5, so we'll be when we round to 4 decimal places, we'll be adding 1 to this one. Since this value over here is greater than 5, I'm just adding 1 to this one, and I'm rounding this value to 4 decimal places, and we get 1 positive R on the right side. So to solve for R, I have to get rid of this 1. So for that, I subtract 1 from both sides. This positive and negative 1 will cancel out. So when I simplify this one, I'll be getting 0.0595 equals to R. Okay, so to convert this value to percentage, what I need to do is I have to multiply this value by 100. So 0.0595 times 100 percentage equals to R. So when I multiply this value by 100, so the decimal point has to be moved 2 digits to the right, then I'll be getting 5.95% equals to R. So to the nearest hundredth of a percentage, Joe's investment pays interest at 5.95% per year compounded annually. So the answer for this question is 5.95%.